Afternoon, everyone. Thank you for joining me today. My name is Vamshi Konapuram, and I'm excited to present my capstone project titled Chicago Traffic Crash Analysis and Modeling. This project was completed as part of Data 606 at UMBC and focuses on analyzing the factors influencing traffic crashes in Chicago. This to inform the safety measures and urban planning. Here is the agenda for today's presentation. We'll begin with an abstract, followed by an introduction to the project. Then I'll provide the details about the dataset, explain the workflow and exploratory data analysis, and discuss the machine learning models used. Finally, we'll review the model performance and conclude with the key findings and implications. The objective of the study is to analyze the factors affecting the crash frequency and severity in Chicago. Especially, we'll examine the temporal patterns, spatial hotspots, and the impacts of infrastructure, road conditions, and human behavior. The goal is to provide the actionable insights that enhance the road safety and reduce the injuries and fatalities. Ultimately, this comprehensive analysis aims to support the data-driven policy decisions of the traffic management. Coming to the introduction, traffic accidents are a significant public health issue, especially in metropolitan areas like Chicago. Understanding patterns and contributing factors is crucial for improving the road safety. This project uses a decade of traffic crash data from the Chicago to analyze the trends and patterns by identifying the high risk times, locations, and conditions. We aim to inform the policies that reduce the crash rates and improve the urban mobility. Coming to dataset. The dataset used in this project is sourced from the Chicago Data Portal and spans traffic crashes from 2014 to 2024. It includes 8.7 million records with the 47 columns detailing crash location, time, weather, road conditions, and more. The dataset provides a robust foundation for analyzing the traffic safety and identifying the patterns that contribute to the crashes. And this is how the data set looks like. We some of the columns I mentioned here are crash data, address, posted speed limit, and I have many which I have not included in this data set. I have nearly 47 columns. So I just gave some reference with the seven columns. Our workflow involved the multiple steps. First, data cleaning and pre-processing were performed to prepare the dataset for analysis. We calculated descriptive statistics and used visualizations to explore the patterns. Geospatial analysis helped to identify the crash hotspots, while EDA revealed the correlations between the weather, road conditions, and crash types. Coming to the EDA, the first one I did was crash analysis that has injuries. Uh, this will show the crash analysis at each year, starting from 2013 to 24. As you can see, the accidents were increased from the period of 2016, and there is a sudden drop down in 2024. Uh, Through the EDA, we discovered that crash injuries are significantly influenced by adverse weather conditions. For instance, the crashes occur more frequently when the weather is cloudy, rainy, or snowy compared to the clear conditions. This insights emphasize the role of environmental factors in the traffic safety. Coming to the machine learning models, to predict the crash severity, we implemented the five classification models: SGD classifier, ADA boost, gradient boost, random forest, and bagging. Each model was evaluated based on the metrics like accuracy, F1 score, recall, precision, balanced accuracy, and ROC area under the curve. Gradient Boost emerged as the best performance model. In this chart, you can see the percentage of each model. Out of this, Gradient Boost achieved the highest accuracy of 89% of the test set with an F1 score of zero point 0.4 and an ROC area under the curve of zero point 0.8. This matrix demonstrates its robustness in the predicting crash patterns. Its ability to handle the complex relationship in this data makes it ideal for the analysis. And here is the Streamlit applications I developed for my project. It's an open source Python library which enables to create you the interactive web application and this is how it looks. Uh, I'll go through the Streamlit application, and this is my applications. Here you can see uh, I given a slide bar for you for easy access, and the first one says that map collisions location with injuries. Like you can slide this bar with the minimum number of injuries, and it will reflect the hotspots in Chicago where the number of collisions occurred. Like if you see the number of collisions, five occurred at these places. You can zoom in or zoom out this map. Coming to this one, collisions by hour. Here I'll give it. I took like the whole day from 0 to 23. Uh, if you check for 0 to 1, which means 12 a.m. to 1 a.m. in the midnight, these are the accidents occurred at that particular hour, and you can slide the bar, check for the remaining hours. And if you see this, like the most accidents are occurred at 4 p.m., like which could be the reason, like all the private corporate offices and schools were shut down at that time. Coming to the third one, collision trends over time. I have given a drop-down calendar, like you can select the own year from 2013 to 2024 and the month and the date, and it will reflect you the collision patterns. Coming to here, collisions by the day of the week. You can select the year and select the day, like it's evening, midday, or overnight. Suppose I selected morning, and it will give the most accidents in the morning are happening on Wednesdays. Like if you select the midday, the accidents are happening on Sunday and Thursday. Here, the collisions by day of the week. You can select the injuries or the fatal, and it will give you the chart for the last one, like I said, with the weather conditions. I have given a drop down of list which are like darkness, light, road, dawn, daylight, dusk. You can select the condition of the weather, and it will give you the number of collisions happened due to that weather. And I also given like it's clear fog or whatever it will give you the number of collisions occurred due to this snow or rainy, whatever it could be. And I have also given this raw data. If you want to see, you can enable this one. And this is about my Streamlit application. Coming to the last one, like conclusion. To conclude, this project provides a detailed analysis of traffic crash data in Chicago. Key findings include peak crash times, midday and late afternoons on Fridays, and accident hotspots across the city. The gradient boost model high accuracy supports proactive crash management. These insights are valuable for the policymakers and urban planners, offering a data-driven approach to enhance the road safety. This methodology can also be adapted to the other cities facing the similar challenges. Thank you for your time and attention. I'm happy to answer any questions you may have about this project. Thank you.